Let's talk about chain rule. Chain rule is one of those rules in calculus that is probably one of the most used, but in my opinion is one of the most oftenly forgotten rule to use. With my students, I usually wear a little name tag on my shirt to class that says, "Hi, my name is Chain Rule," because they forget it so much, because we're just so used to trying to use the power rule that we forget that there's more going on with the chain rule. What is the chain rule? Why do we need it? The chain rule is how to take the derivative of a composite function, or a function within a function. So if we know that derivatives are how to find rates of change, or they're how to find the slope of a tangent line, then we have to think of composite function as being a rate of change within a rate of change. So how do we take the derivative using the chain rule? Well, the chain rule is defined as, if we're taking here the derivative in terms of x of f of g of x. The way we would do that is that it would be f prime of g of x times g prime of x. I like to say it's the derivative of the outside times the derivative of the inside. So we have to come up with unique ways to help us figure out how to take those derivatives a little bit easier. And so let's look at an example of one. So we have the derivative in terms of x of the quantity of 2x plus 5 cubed. So we see we have a function, a linear function, inside of a cubic function. And we want to take the derivative of this. When I teach this to my students, I usually put my hand over the inside function. Or you can almost pretend like you're putting your finger over the inside function. So if I cover up the inside function with my finger or my hand, then it looks like I have finger cubed. So if I'm taking the derivative of finger cubed, we all know how to do that using the power rule, and it would be 3 times my finger squared. All right, well, if I substitute my finger back in, it becomes the 2x plus 5, and then we multiply it times the derivative of the inside function. What was the derivative of my finger? It would be 2. And then we can take all monomials and simplify them and put them in the front, so that would become 6 times the quantity of 2x plus 5 squared. Let's look at a different example. It's a little bit more difficult. So say we want to take the derivative of f of x is equal to the square root of the quantity of x cubed plus 7x. So we have a cubic function inside of a square root function, and we want to try to take the derivative of it. So to use the chain rule, so remember we're saying over and over again, we see the chain rule. It's the derivative of the outside times the derivative of the inside. So let's rewrite the function instead of using the radical sign, using a power. So let's rewrite the function as f of x is equal to the quantity of x cubed plus 7x to the 1/2 power. All right, so now it looks a little bit more like the power rule, or what we want it to look like. But we still have this inside function of x cubed plus 7x. So when we take the derivative, we're going to cover up the x cubed plus 7x with either our finger or our thumb or our hand, and we're going to do the power rule. So we're going to multiply the 1/2 to the front. So it's 1/2 of my finger to the negative 1/2. Now we have to take the derivative of our finger. So the derivative of our finger would be 3x squared plus 7. Now be careful, this is a quantity in itself because it's multiple pieces. So when we go to simplify this, we see that we have 1 over 2, and then we can put our x cubed plus 7x to the negative 1/2 into the denominator, making it positive 1/2. And then we have our 3x squared plus 7 in the numerator. And if we want to change that back to radical form, then we have our 3x squared plus 7 in the numerator times 2, the quantity of the square root of x cubed plus 7x. All right, well, some of you may be thinking, there's got to be a simpler way of doing that, or there's got to be an easier way of writing that so that I can see the power rule in a better way. And there actually is. It's called U substitution. So U substitution is a way that we can basically redefine the inside function to make the problem look super easy. So in U substitution, what we do is we just let U, the variable of U, become the inside function of g of x. So if U is g of x, then we see that U prime would be the derivative of g of x. Now we can use simple substitution. So we can come into the definition of a composite function, and we can change it to be in terms of u and u primes. So it would be the derivative of the function in terms of x, and instead of having f of g of x, we're now going to have f of u. So if we were to take the derivative of f of u, now we just know that that would be f prime of u times u prime, and that's the chain rule piece. All right, so if we look at the exact same example we looked at before with the derivative of 2x plus 5 quantity cubed, we can now define u to be the inside piece. So we're looking at the inside function, or the g of x function. So we'll let u be 2x plus 5, and then we'll make u prime. We'll go ahead and take the derivative of u, which would be 2. So if we go back in and substitute this into our problem, now the problem is changing to the derivative in terms of x times the quantity of u cubed. And we know the derivative of u cubed is 3u squared with the chain rule times the derivative of u prime, or times the derivative of u, which is u prime. Then we simply substitute these expressions back into their variables. So that would become 3 times the quantity of 2x plus 5 squared times 2, which simplifies to the exact same thing we got before, 6 times 2x plus 5 quantity squared. So let's look at our last example. We had f of x is equal to the square root of x cubed plus 7x. So we want to rewrite the function in terms of u. So I'm going to write it down here so I can rewrite it as the power rule first. So I'm going to have x cubed plus 7x to the 1/2 power. Then I'm going to define u to be my inside function, which would be x cubed plus 7x. And then u prime would be 3x squared plus 7. So if we write it in terms of u, we have f of x, f of u, is equal to u to the 1/2. So then the f prime of u would be 1/2 u to the negative 1/2 times u prime. Then we'd substitute back in our u, which would be 1/2 of x cubed plus 7x to the negative 1/2 times u prime, which was 3x squared plus 7. And then I can simplify it just like I did in the last problem, where the 3x squared plus 7 would stay in the numerator, where the 2 and the square root of x cubed plus 7x ends up in the denominator. So in closing, taking the chain rule is a very, very common differentiation rule that we use to find rates of change of composite functions, or functions within functions. So when we're taking the derivative of these, we must remember that we are taking the derivative of the outside function and multiplying it times the derivative of the inside function, so that we take care of all of the rates of change happening in the problem.